to present to you our order assist technology. Before we get started, I'd like to first introduce the team. I am Rick Schmidt. I am the Chief Product Architect, and I'm the project lead of Project BrightLife.
My name is Steve Antoine, and I'm the software extraordinaire and embedded expert.
My name is Kathy Callahan. I am the head hardware designer and the one who will be working on the AutoCAD drawings.
My name is Catherine Smoko. I'm a member of the hardware team, and I am our microcontroller specialist.
My name is Kayhan Baratali, and I'm specializing in hardware and Ethernet communication. And you'll know my mixtape dropped if more manholes start blowing up.
To start off, I'd like to first start with a little bit of the project motivation. We are working with a company called LifeSpire, and LifeSpire basically wants to provide opportunities for disabled workers. And those workers, they specialize in mentally handicapped, basically. And these workers work in an industrial setting, which we'll talk about later. But we as a design team want to build assistive technologies to help provide opportunities for these types of individuals. So a little bit of the project description. So this is an inventory management system. And these workers have a job in a warehouse-like environment. They receive orders. LifeSpire receives orders from large clientele, everything from small nonprofit organizations to large authorities like the New York State Housing Authority, pretty big clientele. So the workers, who are the mentally handicapped people, have to basically fill these orders to make sure and pack the boxes. So just to provide some context, here's some actual pictures of the warehouse environment that we're working with. And what's really important to start off pointing out here is that you work for everything from really small items through very large items. So the technology needs to be very adaptable to any type of product you can really throw at it, and it needs to be, very customizable. So let's talk a little bit about the requirements of the system. So obviously the system has to be assistive to these individuals, but there's also a large number of items that we need to support. And just to provide a context for that first deployment for the New York State Housing Authority, we're talking about several hundred products. But really the system shouldn't be limited by that. You should really be allowed to scale the system to any size that the client really needs, depending on their application. The system must also be deployable with their existing shelving. And we did have a little bit of heritage of this project previously, and those groups actually attempted to build the shelves themselves. None of us are carpenters. I don't really think we should be. So we want to start with basically using industrial grade shelving. This is an industrial environment, and we want to let them bring their own shelves and let our technology easily deploy on those types of technologies. Furthermore, the system should integrate with their current inventory system. You don't just walk in and completely uproot someone's workflow. You want some kind of integration with their existing systems. To continue, the system must also account for various user roles, and we'll discuss this in more detail briefly later. The system also needs to provide a way for managers to do inventory audits. There's user error, and we're also dealing with the mentally handicapped, so that's more prone to error, and we want to minimize this as much as possible. And finally, the system, and probably most importantly, the system must be user-friendly because of who is using the system. So enter our technology. We like to call it Order Assist. And so before we go into the nitty-gritty details, I want to give you a conceptual level of the project. So imagine an array of products on a shelf, and each box represents a particular type of a product. And imagine a system that could actually point a disabled worker to a particular item on a shelf. That way, with their fill order, they know, oh, I need this item. There's hundreds of variations. It might be clothing, different sizes, different genders, etc. It'd be very hard to discern these different things, and you're looking at barcodes. So imagine a system that can actually show you which one to get. So what this system actually does is above each item, if you can imagine a light placed above each one, it simply lights up so the user knows, oh, I need to get this particular item. So to continue on, I'd like to invite Catherine Smoko up to discuss the system users and their roles.
Thank you. So there are three main users that will be interacting with our system. The first and probably most important is the order processors. Those are the employees hired by LifeSpire that we've been shaping this whole project for. So their workflow as it exists, or as we intended to exist with this product, is that they'll get assigned a color from their manager. So an employee maybe gets red one day, so they know that that day they have to look for boxes that light up red. And they need to go to those boxes, find those items, and when they find those items, they can scan it, put it in their package to get it ready for shipping, so to make their lives easier. The next users for this system will be the inventory inventory stockers. Now, traditionally at LifeSpire, inventory has only been stocked by managers because it's like a really important job, and there needs to be like as minimal errors as possible. But with our system, we're hoping that it could create more jobs for those who are mentally handicapped, because this makes this job even more simple. Because the system will let the manager know when inventory is low, and someone stocking inventory can restock it, scan the item, and retell the system, we're not low on this anymore, we're okay. The final users of the system will be the managers. They're the ones that are going to assign the colors to the employees. They will also be able to use the system to check inventory and orders, and as well as perform audits. So we're going to jump into the key system modules of our product. On the hardware side, there are 4 system modules: the LED controller, shelf controller, central controller, and wireless hand scanner. So to just give you a brief overview on each one, the LED controllers consist of RGB LEDs that are self-addressable and light up with the proper color of the order, and then turn off when the product has been scanned and therefore placed in the packaging. This LED controller communicates and is powered by Ethernet from the shelf controller. The shelf controller there's one shelf controller per shelf, so the shelf controller controls multiple LED controllers, as I don't know if you remember back to Rick's big picture slide there. So there's one shelf controller per shelf, and the shelf controllers, as I just mentioned, communicate with Ethernet to the LED controllers, telling them which LEDs need to turn on and what color, and it receives that message wirelessly from the central controller. The central controller is the main hardware-software interface of the whole system. I just mentioned it communicates wirelessly with the shelf controller, but it also communicates with our database and our desktop software that Dave is going to be talking about briefly. And also it communicates with the wireless hand scanner. So the shelf controller is the central controller is pretty much what makes everything communicate with one another. So the wireless hand scanner is fairly self-explanatory. This is going to be the main human interface of the system. So when the user scans something, it'll probably make like a supermarket beep, kind of telling them like, you scanned the correct product. The hand scanner will tell the central controller this product scanned. The central controller will tell the shelf controller, okay, turn off LED 3 on shelf 2, and it will work in that kind of manner. So as I just mentioned, Dave's going to come up and talk about the software key modules in the system.
Okay, so on the software side, we have the desktop software and the database system. The desktop software is the main interface for the managers at the facility. The managers with the desktop software can assign specific colors to each individual employee. They can also oversee inventory and orders at the facility. They can also perform weekly audits on said inventory. With the database system next is the back end of the desktop application. With the database, we store the invoice information, the product information, and the information of different vendors. The database also stores the current inventory at the facility and where each specific product is mapped on the shelf system. The database also synchronizes with the company's current QuickBooks software when they perform their weekly audits. So next, you see our system architecture and each individual component of our system. You can see that the shelf controller, the central controller, and the hand scanner each communicate with each other wirelessly, and that the LED controllers cascade with each other with respect to the shelf controller. So next, for risk analysis, to minimize risk, we experiment and design each individual component before actually implementing that component. So we start on a small scale, then we build upon that. This way we can catch bugs early on and lessen the impacts these bugs may have on us in the future. For testing, we use the unit testing method. So we test each component individually by itself. If a component fails an individual test, then that component cannot be integrated into the system. So we start on a small scale with a component, see if it works, integrate it into the system, and repeat that process until we have our whole system built. So, and also, examples of tests we've performed so far on the hardware side, we have a boot up sequence which tests each individual LED controller to see if it's working. And on the software side, we perform user-driven tests on our desktop application Next, I'd like to pass it over to Cam to speak about the bill of materials.
Okay, so the bill of materials here is a list of components that make up all the key modules of the system. And the most crucial ones would be the Raspberry Pi, which is going to be taking the role of a low-cost embedded computer. And the Zigbee would be handling all forms of wireless communication within the entire system of the order assist. And we'll be using the RGB LEDs because they're not aware that it's just self-addressing, but they're also a customizable color. So we could have more than 3 workers working because we could also cover colors such as like anything beyond like red, blue, and green, full color spectrum. And we're going to be using MySQL as our chosen database engine. And now this is how many of each component our design is going to call for to make this all happen, as well as calculated costs. But this is for 2 shelves and 5 workers. But since we designed this with scalability as such a priority, we could change these numbers to be whatever we want based on the client's needs. But for this one, for 2 shelves and 5 workers, and since Livespire was kind enough to lend us 2 computers and appropriate software, this only came out to $1,200 just about for our budget. And everything is on schedule thus far, and over winter break we're planning to conduct further research on Zigbee wireless communication as well as lay out our PCB boards. And we're going to be installing Windows 10 onto our central controller and be using Socket Server Desktop app as a means to communicate with it. And then when we come back from winter break in February, we're going to further implement all the research we've done over winter break and finally introduce wireless communication into the system. We'd also be beginning the development of the hand scanners as well. And if everything continues at the pace it's going at, we're going to have a fully functioning deployment ready by April for installation. And I'd like to trade over to Katie Callahan so she can discuss our current progress so far.
Okay, so up to now, we have 40% of our project completed. We have a fully working shelf controller circuit that we designed, and we also have the LED controllers that are fully designed and implemented and can be cascaded into any large amount. And we have the boot up program that Dave mentioned that serves as a unit test for ourselves, and it also serves for when managers come into work in the morning, they turn on the system, they will watch every light on all of the shelves turn 3 consecutive colors in 3 rounds to make sure that every light is working appropriately. Then the desktop software is currently importing the inventory documents we received from Livespire into our system, and the database is fully created and ready to start storing data once wireless communication is added. This is one of our RGB LEDs that we have. It comes in a big long strip, but you can cut them individually. So this light can be any color possible. We have red, green, and blue currently because they're very decipherable, so it's easy to say, you know, like blue and purple can kind of get confused, so we have very different colors. The box that it's sitting on is also right here, so it's pretty tiny. So this will be what is actually mounted to the shelves, and we'll have like double-sided tape or magnets, so it's very easily installed and movable and can adapt to big products, small products. So then, to show how the system is actually working, we have a video of our prototype. Okay. So we have, it'll show the boot up system right now. So it goes through every color. The shelf controller circuit is up in the corner. It is driven by a 15 volt power supply and uses a voltage regulator to supply 5 volts constant DC to the circuit, which is needed to drive all the LEDs. Each project to work on, and we also want to thank AJ Wiring for providing us with our local parts and consulting. Are there any questions?
Thank you. First would be more of a capacity question. I know things are scalable. How many use factor water processes anticipate?
I'm sorry, how many
Water processes.
order processors? So right now they have like very minimal on there, so that's going to be partly decided on how they want to partition the system. That's really more of a deployment choice there. So if right now basically they're designing the geometry of the warehouse, and they're actually thinking about reorganizing the way the products are mapped out in the warehouse to meet the needs of the system. But right now they want to create aisles essentially, where like all the items needed to fill a particular item is in a particular aisle. So the number of users are going to be limited on a per aisle basis, and our desktop software, the product mapping based upon the database and everything, you could like list that type of product at multiple locations. So if you need to, have like a localized inventory on a per aisle basis, so it's based upon like it's arbitrary based upon like how many you want to set, like during installation time.
Do the order processors have only one order to process at a time?
That's
Yes.
correct. So does anyone want to cover that?
What is your question?
That was a yes
Oh,
or no.
Yeah.
Oh,
They
yes.
will pick a form and scan like the barcode on the form, and then the
Everything
appropriate lights turn
involved
on.
in that order will be of that color.
All right, then two kind of like questions. What if two order processors had command from the same handle?
That's a great question. And there's actually two solutions we're looking at for that. So the idea of scanning a printout order, and that's what gets assigned, that was something that the client had an idea. We actually want to propose a system that's actually going to print out them to assign it. So if we go with the condition of the printout order that they pick out, when they scan it, it's going to go, you can't take this one, so they'll pick up another one from the pile. So the system will actually be aware of the items actively being taken up on them. Because you can't be two colors at once. You have
we
to
think
lock
that-
the local inventory.
And we think that we considered maybe like flashing different colors, but we thought we were told the mental capacity of these people is about 50% of the average person. We thought that would potentially be way too confusing, and so we definitely want to keep it one constant color for the employees filling these orders. So we didn't want to have to worry
And I'm
about
sorry, I just wanted to ask a question.
Sure.
The rate operation. What if a shelf control failed?
If the shelf controller completely failed,
Lights on that shelf.
so like they failed the moving of the morning boot up sequence.
Yeah, there was no light, no active.
Okay, so each of these things are hot swappable. So you literally, so the shelf controller, it's fully encapsulated. It would also be in a similar kind of box. It's a simple wall outlet on one end, and it's plugging. It has an Ethernet out on the other. So to replace this, if you have local extra right on hand, 10-minute fix.
Take it
So
out, unplug it,
minimum time to
replug.
replace.
Yeah,
Yeah.
very minimal time to replace. And that's why everything's individually addressable on startup. That way we're not hard assembling an address anywhere.
I'm sorry for dominating this, but what about the handheld? I didn't hear anything about the handheld development.
Yeah, sure. Does anyone want to?
Well, we haven't. We haven't really gone into that design a whole lot yet. But we know that there's a lot out there on hand scanners. It's not an uncommon technology. The only thing is that it's going to scan barcodes because the company can print barcodes with their QuickBooks software. So, that's really easy for them. So it'll be able to scan the barcodes, and it will communicate wirelessly to the central controller, telling it this has been scanned, meaning this person has put this item in their box. So you can turn off this LED or change it to a new color if there's an order waiting on that box. So it's
just-
probably going to use Zigbee wireless communication is what we're anticipating.
I'll be quiet. Thank you.
Thank you.
So you said the mental capacity of these people could be 50% of normal.
Right.
Yeah.
Okay, so after
What
finish
contingency plans
everything,
do you have
on
for
the side
colorblind?
meeting.
Maybe them not recognizing that they are colorblind or how bad it actually is.
Yes, that's a great question. So the colors aren't assigned by the system. That's actually a human, like the manager actually assigns that. So any kind of accommodations that they need to make is very easily correctable on a human, like on a manager level.
So there is way worse, so I'm registered colorblind. There's way worse colorblind. Do you have like a grayscale in mind or some kind of other way of showing like analog light?
So those lights are actually, if anyone wants to jump in on this. But those lights, we can make it any single color. We have full 21-bit color, so as much versatility there is as a computer pixel. We could make that any arbitrary color. So.
And it could be, like, if they realize that the employee is colorblind, I'm sure they can figure out which color they see best and make sure they assign that employee that color always, so they know.
Okay, we're gonna have to wrap it up here. I apologize for the technical difficulties that we had